Okay. Integration then. It probably doesn't surprise you, given that we've just looked at how we can sort of differentiate to move down and solve problems, that we can integrate up. Okay. One thing just to remember about integration is that we need a coordinate. Okay. Otherwise, if we don't have a coordinate, we don't have limits, we get stuck with C. So one thing you'll see in this question is if you need to use integration, you'll often be given a little bit more information, and that allows you to work out this C and then create your own full equation. So let's have a look at an example. So a particle is moving on the x-axis at time t equals 0. It's at x equals 5. So when you practice a lot of these questions, what you'll do is you'll spot that that's probably some information that you're going to use to find C in a second. The velocity is given for positive values as this. So the velocity equals 6t minus t squared. Find an expression for the displacement, at time t seconds. So they want a general expression for displacement. Well, what's the relationship? We integrate velocity with respect to time to get displacement. So 6t is going to become 6t squared, divide by the new power, minus t cubed, and again divide by the new power, plus c. Okay, so that's your displacement, s equals. Now, we were told when t equals 0, x equals 5. They've used x here instead of s. So you can put that information in, and it allows you to find out your c. Well, that's going to be a 0, 0. So 5 is going to be equal to c. And then what you can do is you can clean all of this up, and you can make your final equation. So x equals 3t squared minus a third t cubed or something like that, plus 5. That's your complete expression. Okay. So spot that you need to integrate, you're left with plus c, but there should be some information somewhere in the question to help you find the c. And once you've done that, this is called a complete equation. So this is a full equation. It says an expression, actually, it's an equation the way we've written it. What's the distance of the particle from its starting point? From its starting point, that's the definition of displacement. So nothing special we need to do here. We just put t equals 6 into our new equation, and that gives us our answer. Okay. 41. Oh, sorry, no. From its starting point, we started at 5. So we end up at 41, but we were actually at 5. So the distance between those is 36. So there you go. I fell into the trap of answering that question a bit too quickly. Anyway, so turning points can be useful for differentiation, moving between them. Integration is useful for moving between them in the other direction, but it will also often involve a plus c. Let's have a look at one more example. So here's our velocity given. Find the distance traveled by the particle in its third second of motion. In its third second of motion. Well, that means when we're integrating, we're going to try and look at between which seconds, if we try to have our third second of motion. Well, it's from when the second one has finished until sort of the third one is complete. So we're going to integrate between 3 and 2 in its third second of motion. Kind of a little bit tricky, that one there. But really, it's just reminding you that you can integrate and have C and try and find C. The question could go that way. That's called indefinite integration. This is called definite integration. Okay, so it's in the third second of its motion. So after the second one has finished, so when you're at like 2.1 seconds, 2.5 seconds and stuff, this is all called being in the third second. Okay, so from 2 until 3. We've got one more example here. So a particle moves on the positive x-axis, the velocity. So we've got a velocity given. When t equals 0, p is 15. That sounds like a coordinate to get c. What what are the values of t when we're instantaneous rest? So that means rest means v equals 0. And I've got v already, so I can just solve that quadratic. Okay, values. So 2 answers. That makes sense. What about the acceleration? Velocity to acceleration, so we're going down. So acceleration is going to be what? If I differentiate this, I'm going to get 4t minus 9. Yeah. And it says put t equals 5 in there. So we're looking for 11. Yeah, 11 meters per second squared. The total distance, the total distance traveled in the interval 0 to 5. So if I want to know what distance is traveled, we might want to start by thinking about what happens to the particle. So let's have a look at the velocity again. It starts at 4, and it's a positive quadratic, so it's a smiley face. Do I know that it stops at any points? Do I know that it intersects? Yes, I found that in part A actually. So that's 0.5 seconds, and that's 4 seconds. So it does something like this. Now, we want to find the integration, because we're finding distance. And another way of thinking of that is the area under the curve between 0 and 5 seconds. Can you see a problem if you think back to your work on integration? What's the problem if I just integrate between 5 and 0 here? I've got a positive area. I've got a negative area. I've got a positive area. If I just do it all in one go, they're going to cancel out. Okay? So what I need to do here is I need to break this down. I need to integrate between 0.5 and 0. I need to integrate between 4 and 0.5. And I need to integrate between 5 and 4. So that's quite a lot of work. That's why it's 5 marks. And it's happening because the particle is sort of traveling in the positive direction, and then it slows down. And then it starts to travel in the negative direction, and then it slows down. And then it starts to travel in the positive direction again. And I can see that from the graph and thinking carefully about it. So break it down into the different sections. 1, 2, 3 parts there. And we get our final answer as 233 over 12. Okay, so that last question there takes a little bit of time. But so it should. This is 11 marks. So have a go there at the question on the board. Okay, pause the video, have a go at that question there on the board. And the answers are there on the screen. So that now takes you up to exercise 11D.